So let's look at one of the example, which is factorial of a number. So, so you know what is a factorial of a number? It is basically nothing but, let's for an example of the factorial of 5 would be 5 into 4 into 3 into 2 into 1, and factorial of 6 would be 6 into 5 into 4 into 3 into 2 into 1. When it comes into your mind, and whenever you need to calculate this, you might be thinking, I can use a for loop, and also you might think like, for this one you can also use a for loop. But if I tell you, you have to do something. See, for loop is one of the solutions. It's like alternative to solve a problem. But one of the beautiful concepts in programming is about recursion. Recursion basically leads to dynamic programming. Essentially, when we refer to recursion, we try to find the small, suppose you have a very big problem, and you only, with recursion, with the help of recursion, you try to solve a base part of it, and the rest part is solved by itself, or in the form of recursion by calling itself. You just need to know what are the base cases. For example, if a base case, you solve for a very simple unit of a very big problem. Very simple unit. This is a simple unit you solve using recursion, and this problem, the rest problem, you don't need to worry about. The rest problem will be solved on its own. That is the beautiful part about recursion. Now, coming to the question of finding the factorial of a number, as we discussed above, 5 factorial we know, 6 factorial we know, 7 factorial we know. Can we go on till 100 factorial, maybe 1000 factorial? So the thing with factorial is this can be solved recursively. And how am I saying that? For 5 factorial, we know that it is 5 into 4 into 3 into 2 into 1. And for 6 factorial, I can say 6 into 5 into 4 into 3 into 2 into 1. Now, if you notice this, this 6 factorial can also be written as 6 into 5 factorial. This is nothing but 5 factorial only. So I can write it as 6 into 5 factorial. In recursion, you have two things to deal with. First is base case. Second is your generalized expression to solve that problem. So suppose for 6, if you're trying to calculate, for 7 factorial, if you're trying to calculate, I can write it as 7 into 6 factorial. Alright. For 100, what I can do is 100 into 99 factorial. For, let's say, suppose we are trying to calculate for n factorial, we don't know what, n could be a very large value. So how we can solve this? We can say it, if n factorial is equal to n into n minus 1 factorial, and this is our generalized expression to solve our recursive problem. And this is how we have found the generalized expression. Now, so let's find out what could be the base cases. For the base cases, always start with the small, the unit value that can fit the problem. For example, if someone says me find the factorial of n, I would simply try to find out what is the meaning of the factorial. So for the base case, I'll take the smallest unit possible that fit in the scenario, which is 0 factorial. And we are not talking about the negative numbers. We are talking about the positive numbers, including 0. Now, 0 factorial is equal to 1 from the mathematics. 1 factorial is equal to 1. For 2 factorial, it is equal to, I can say, from a generalized example, I can say it is 2 into 1 factorial, which is true. For 3 factorial, I can say it is 3 into n minus 1 factorial, which is equal to 3 minus 1 factorial, which is equal to 2 factorial. So now we know our generalized expression solves what can come next for the n, what value can come next for the n, or n could be anything in the positive range including 0. So the base cases only we need to worry about is these two, 0 and 1, and these are our base cases, and this is our generalized, this is the base case, and this is the generalized expression. And when we have got these two, we can definitely write a recursion program, and I'll write it right here. Allow me a second. Yes. Now let's define the recursive function, which is def fact n if n is equal to 0 or n is equal to 1. What I want to do is I want to return n only. Basically that means is if n has the value 0 or n has the value 1, it should return n. In this case, if n is equal to 0, it will return 0. If n is equal to 1, it will return 1. Now, in the else part, we will write our generalized expression. In the else part, the generalized expression as we have solved here is equal to return n into n minus 1 factorial. Look at over here which I'm pointing. It's like almost like a laser, and I'm just highlighting it for the sake of to understand what is there on my screen. Now return n into factorial of n minus 1, and in these 1, 2, 3, 4, 5 line of code, without using for loop, you are able to solve something big just by understanding the base cases. Just by understanding the base cases, this is our base case, and just by sorry defining our generalized expression, we are able to solve something big. So for recursion, always try to think about the smallest possible unit that you can solve, and based on that you can solve a very big problem. Only two things that you need: first is the base case, second is the generalized expression. So I'm going to write it again. This is the base case. Handle the base cases and write a valid generalized expression, and you are ready to solve with the recursion, and your recursion would be correct 100%. Now let's see how this works. to copy it. I'm going to paste it over here just for you. You can see the code as well as what I'll be doing here. Sorry. Let's understand this by how this works behind the memory, like behind the programming, how the Python handles it, and how it goes onto the memory stack. Suppose this is the memory stack of your program. First it loads factorial n. Then it pushes this when it comes here. If it checks n is not equal to 0 or not equal to 1, then it comes to return n into n fact of n minus 1. This is n into fact of n minus 1. Now here, if this always returns the value, this always returns the value here. If this block is solved, if this stack is solved, it will return the value to the lower stack. And if it is the last loaded function on the stack, then the function ends here. And this returns the value to the program, returns the final value. Let's see how this works. Suppose we are trying to calculate the factorial of 5. So if n is equal to 5, it goes, the n goes to the place of def fact 5. And we know that n is not equal to 0 or 1. So it returns the value n into fact n minus 1. So fact 5 basically calls n into, what is n? N is 5. 5 into fact of 5 minus 1, which is equal to 4. Okay. Now this calls. Now when the fact 4 executes, the function is calling itself. So we know it's a recursion. Now if n is equal to 4, suppose I'll point it out. If n is equal to 4, we know that n is not equal to 0 or it is not equal to 1. So it will come down to this statement where it will return the value n into fact of n minus 1. So I'll do it again over here, which is equal to 4 into fact of 3. Okay. Now it will do one more thing for me. On the fact 3, the n the n will be 3 now. We know that 3 is not equal to 0, it is not equal to 1. So it will return the value, which is 3 into fact of 3 minus 1, which is equal to 3 into fact of 2. Okay. Now coming to the fact of 2, when we know n is equal to 2, okay, n is equal to 2, we know that n is not equal to 0, it is not equal to 1. So it will come to the else statement where it will return the value of 2 into fact of 2 minus 1. Which is equal to 1. Now this is where our base case comes into the picture. Now with the base case, we know now the value of n is 1. So if n is equal to 0 or n is equal to 1, it will return me a value 1. So what this will do, this will return a value 1. This will return a value 1. And now this is combined 2 into 1, which is 2. And this will return a value 2 to the fact of 2. And 3 into 2 will club together, will make 6. And they will return a value 6 to the fact of 3. And this 4 into 6 will be clubbed together, and this will return a value 24 over here. And this 5 into 24 will club together, and this will return a value of 120, which is our solution for this case. So this is the explanation I can give you for how factorial works in the background by making some branches. This is basically a tree diagram of recursion. Now let's see how it hops onto the memory or the memory stack. I'll create something over here only. I'll make my pencil smaller. Okay. The first time when we call 5, we know that n is equal to 5. The first time we call n is equal to 5, the first function that is loaded, that is pushed onto the stack is fact of 5. Now, we know that n, so what were the base cases? N should be when n is equal to 0 or n is equal to 1. The base cases were when n is equal to 0, return 0. If n is this should be like this. The representation should be something like this. If n is equal to 0, return 0. If n is equal to 1, return 1. Else return n into fact of n minus 1. So we know that n is equal to 5. So in the next statement, it will when this fact of 5 is called, it will return me a value which is n into fact of 4. And this, when fact of 4 is again called, it will check for this statement, it will check for this which does not satisfy. So it will again return me a value of n into fact of 3. Similarly, when n is equal to 3, it will return me a value of n into fact of 2. Similarly, when n is equal to 2, which does not satisfy n is equal to 0, which does not satisfy our base cases, so it will return me a value of n into fact of 1. Okay. Now, when fact 1 is when n is equal to 1, when fact 1 is called, so we know that 1 is in our base case, and it will return me a value of 1. So n into 1 is returned. Sorry, why I have been writing n for the times. It should be 4 into, sorry, my bad, 4 into, sorry, just give me a moment please. 4, it should be 5 into 4, it should be 4 into 3, it should be 3 into 2, and it should be 2 into 1. So we know that n into fact of n minus 1. When we call fact 5, 5 into fact of n minus 1, which is equal to 4. When we call 4, it should return a value of 4 into fact of n 4 minus 1, which is fact of 3. And when we call fact of 3, it should return me a value of 3 into fact of 3 minus 1, which is fact 2. And when we call fact 2, it should return me a value of 2 into fact of 1. When we call the function fact1, so we know that it lies in our base case, so it returns a value of 1 to the program when fact1 is called, and these two into 1 is calculated and it is returned to fact2. The fact2 gets the value of 2 and 3 into 2 is calculated, which is equal to 6. Okay, and it returns to the value of fact3. So 6 into 4, which is equal to 24. It returns the value of to fact4. When fact4 called, it returns the value of 24. Now these two are clubbed together, 5 into 24, and these return the value to fact5, which is 120, and the function ends here. Recursive function ends here. And this is my explanation and what happens onto the memory stack and what happens during the tree diagram of recursion. So I've tried to explain it in both ways. I hope you guys learned something out of it. Please do let me know if I can improve anywhere during my video lectures. And also please share and subscribe to my channel. This will help me grow. And thank you so much.